Hello and welcome everyone to this channel. This is Professor Rajesh Barapate, a book author of 25 plus engineering books. Without wasting the time, let us dive into the topic. Dear students, today's topic is node analysis or KCL. KCL stands for Kirchhoff's current law. The statement is at any node, summation of incoming currents is equals to summation of outgoing currents. Dear students, in today's lecture, we will be discussing the meaning of this statement and we will be solving few numericals to get an idea of node analysis. So, as an example, I will mark one dot. This dot, I am calling it as a node. I will mark some branches like this. I am assuming 5 branches. In each branch, I will mark the currents. I am marking the direction of currents randomly, like this. And I will mark some notations. So let us say this current is I1, second is I2, then next is I3, next I4, and next I5. Look at the statement. What statement indicates? Summation of incoming currents is equals to summation of outgoing currents. As I said, this point is called as a node because this is the junction point at which different branches are connected. So it is called as a node point. What are the incoming currents towards this node? Very simple. Look at the arrow. If arrow is towards the node, these branches or the current flowing through these branches are called as incoming current. Look into this diagram. Here I1, the direction of current I1 is towards the node. I2 is away from the node. I3 is again towards the node. I4 is away from the node. And I5 is again away from the node. So incoming currents are I1 and I3. How I judged? From the direction of arrows. So I will mark the notations in the statement, that is incoming currents are I1 plus I3 is equals to, what we have written? Summation of outgoing currents. So outgoing currents are, look at this diagram, outgoing currents are I2, I4 and I5. So I will write I2 plus I4 plus I5. So I have written the mathematical equation according to the statement of KCL, that is node analysis. Let us solve some numericals to get an idea how to implement this statement. The question is calculate current through branch AB using KCL, that is Kirchhoff's current law. It is also called as node analysis. This is the given diagram. The branch AB contains a resistance of 3 ohm. Now, what is given in the question? There are 2 voltage sources. This 5 volt is one voltage source, 4 volt is another voltage source. Do remember the basic points. In case of voltage source, the longer terminal indicates positive. So this is the positive terminal, remaining is negative terminal. Similarly, for 4 volt, the longer terminal indicates positive terminal, remaining is negative terminal. Now in the question, the directions of current are not given. So I will assume some currents, like through this branch, I will say this current is I1. In the second branch, I will say this current is I2. In the third branch, I will mark this current as I3. The question arises how I have chosen these directions. Directions are immaterial. You can well choose the directions, like I1 I am showing from LHS to RHS. You can well consider it from RHS to LHS. But keep in mind that if voltage source is there, current always comes out from positive terminal of battery or positive terminal of source. So I have assumed the current coming out from the positive terminal. So direction of I1 is like this. Similarly, in this case, from 4 volt, this is the positive terminal. So direction of I2 is from positive terminal, like this. By default, in any network, the bottom line is considered to be a grounded, that is 0 volt. So the tendency of current is always passed towards the ground. So through this branch, I have considered I3 going towards the ground terminal, that is going towards 0. Even in case, in the exam, suppose you will mark the directions in opposite way, it will not make any difference, answer will remain same. Only the case is that the calculated answer will be negative if it is originally positive. That's it. Okay. So as I said, I have marked some notations like I1, I2 and I3. Now, one more basic thing. Before solving the numerical, we'll discuss how to do the calculation. Suppose I have one resistor like this, whose value is R, and I am assuming that current I is flowing through this resistor like this. At one end, I will mark voltage V1. At another end, I will mark voltage V2. I have marked that current I flows from V1 to V2. That means V1 is having larger value than V2. Now, according to the Ohm's law, I is equals to V upon R. This is the basic Ohm's law. In this case, since I have considered that current I is moving from V1 to V2, so as I said, since it is moving from V1 to V2, V1 is larger than V2, so I will write V1 minus V2 upon R. Suppose if the direction of current is like this from RHS to LHS, then in that case V2 will be larger than V1, and equation of current in this case I can write it as V2 minus V1 upon R. These are the basic things what we need to implement in the diagram. The first part is we need to identify how many nodes are in this diagram. See, what I said, node is a junction where different branches are connected. For example, this point is a node because this is 1, 2, 3. 3 branches are connected, but since this is a bottom line, it is considered to be a grounded. So don't mark any notations over there. Now, can I say this is a node? No, it is not a node. Actually, it is a single wire like this which is bent to draw this diagram. So this point is not a node. Then, is this a node? This is again not a node. As I said, this is a single wire which is bent. This point is a node because 1, 2 and 3. 3 branches are connected. So this is the node. So we have marked in this diagram that there is one node at point A. I will assume the voltage at this point is VA because it is connected at point A. You can assume any notations. This is not a node as well as this is not a node because it is a single wire. Only this is the node where 3 branches are connected. This is the first step. What we did, we calculated, we identified how many nodes are there in the network. So in this network, there is only one node. The bottom line is connected to the ground. This is one more node, but we are taking it as a reference. Next step is, I have marked the current, directions of current in the diagram. According to the statement of KCL, incoming currents is equals to outgoing currents. Look at this node. Incoming currents are currents flowing towards this node, towards the VA. So incoming currents are I1 and I2 because arrow of I1 and I2 is towards node VA. While outgoing current is I3 because it is away from node VA. So I will write the equation I1 plus I2 is equals to I3. Very simple. Incoming currents towards the node are I1 and I2. Outgoing current is I3. So equation is I1 plus I2 is equals to I3. Just now we discussed how to write, how to express current in terms of voltage. Look at this current I1. Current I1 is flowing through 3 ohm. I will draw the separate diagram for this just for the simplicity. This is 3 ohm through which current I1 is flowing. At one end of 3 ohm, 5 volt is the voltage source. At another end, I have marked this voltage at VA and we have assumed the current flowing from 5 volt to VA. That means 5 is larger value than VA. So equation of I1 will be 5 minus VA upon 3. I have written equation of I1 5u minus VA upon 3. Same way, if I want to write equation for I2, look at I2. Again, I will draw the separate diagram. This resistance is 2 ohm through which current I2 is flowing. At this end, there is a node whose voltage we have assumed equals to VA. At another end, we have a battery whose value is 4 volt. We have considered the direction of current I2, that is from 4 volt to VA. So 4 is larger than VA. So equation of current is this plus sign remains as it is. Equation of current I2 is 4 minus VA upon value of resistance is 2. This is the value of resistance, which is 2, equals to. Look at I3. I3 is flowing from VA towards ground, towards 0. So at one end voltage is VA, at another end voltage is 0. So this equation of current I3 is VA minus 0 upon 3. Next part is pretty simple. I just have to simplify the equation like this. 5 by 3 minus 1 by 3 VA plus 4 by 2 minus 1 by 2 VA is equals to VA by 3. Now 5 by 3 is 1.67 minus 1.3 is 0.33 VA plus 4 by 2 is 2 minus 0.5 VA is equals to 0.33 VA. Remaining part is simple. You just have to simplify this equation. Now the next part is I have to arrange the equation such that VA will be at LHS and constant will be at RHS. So let us rearrange the equation like this. It is minus 0.33 VA, that is this term I have taken, minus 0.5 VA. Next term, I have to take this term towards LHS, so it becomes minus 0.33 VA is equals to this constant terms. There are two constant terms. I will add these two terms, that is 1.67 plus 2 becomes 3.67, and I will transfer it to the RHS. So it is minus 3.67. Take VA common, perform the addition. So next equation will be, now let us add these terms at the LHS. So it will be minus 0.33 minus 0.5 minus 0.33, it will be minus 1.167 VA is equals to minus 3.67. Therefore VA will be minus 3.67 upon minus 1.167. So it is 3.14. You can well do these calculations on the calculator. So VA is 3.14. But in the question, VA is not asked. What is asked? It is asked to calculate the current I3. Refer the equation of I3, which we have written earlier. So equation of I3 is this equation. VA minus 0 upon 3. So I will write I3 is equals to VA minus 0 upon 3, which is VA upon 3. That means 3.14 upon 3. Therefore, I3 is equals to 1.04. Since it is a current, its unit is ampere. So this is the calculation using KCL, that is node analysis. Dear students, I have solved one numerical to get an idea how to apply the node analysis. If you like the video, please smash the like button and don't forget to subscribe the channel so that you will get updates of my new videos. Thank you very much.